Hey everyone, Geek37 back with another video, and this is part 27 in my Exploring the Heptagonal Triangle series. And we are going to do an analog of a relation I solved earlier in this series, namely b squared over a squared plus c squared over b squared plus a squared over c squared equals 5. This time the variables are raised to the fourth power, and instead of being squared. So b to the fourth over a to the fourth plus c to the fourth over b to the fourth plus c to the fourth over a to the fourth. And this will be needed to do a calculation in the next video I upload. Now, in order to do this correctly, we have to appeal to an algebraic identity that I have labeled in that purple color down below the heptagonal triangle. It is x squared plus y squared plus z x plus y plus z quantity squared equals x squared plus y squared plus z squared plus 2 times the quantity xy plus yz plus zx. Okay, so here's what we do. I'm going to rewrite the first identity here that I had mentioned earlier, b squared over a squared plus c squared over b squared plus a squared over c squared equals 5. We are actually going to show this written squared. So b squared over a squared plus c squared over b squared plus a squared over c squared, quantity squared, and that will equal b squared over a squared, quantity squared, plus c squared over a squared, quantity squared, plus, b squared, my bad, plus a squared over c squared, quantity squared, plus 2, and I hope I have enough space to write this, b squared over a squared times c squared over b squared plus c squared over b squared times a squared over c squared plus, let me do this quick, let me move this guy out the way. I'll erase this guy, and then we will be able to write in. And then we will do a squared over c squared plus b squared over a squared. And of course, that appeals to the last part of that identity. So we're taking 2 times 2 and then parenthesis the first 2 terms of that, the part that's quantity squared on the same side of the equation, and then the last 2, and then the first and last one to get that. And what happens is by showing these squareds here, we get a number of cancellations. The a squared, the b squareds cancel, the c squareds cancel, and the a squareds cancel. So what will happen is we'll get b squared over a squared plus c squared over b squared plus a squared over c squared, all that quantity squared equals b to the fourth plus a to the fourth plus c to the fourth over b to the fourth plus a to the fourth over c to the fourth plus 2 times the quantity c squared over a squared plus a squared over b squared plus b squared over c squared. And the interesting thing is, let's change this to a different highlighter color. This part here in orange that I'm showing marked is going to be the same as a squared plus b squared over plus b squared over c squared plus c squared over a squared equals 6. So what I'll do is I'm going to write down first off on the right side of the equal sign b to the fourth plus a to the fourth plus c to the fourth over b to the fourth plus a to the fourth over c to the fourth plus 2 times 6. And on the left side of the equation, we have b squared over a squared plus c squared over b squared plus a squared over c squared, all that quantity squared. And as you know, it's equivalent to this part here that I had marked in yellow at the start of the video. I'm going to replace that with the number 5, and that will be 5 squared. So we'll get 25 equals b to the 4th over a to the 4th plus c to the 4th over b to the 4th plus a to the 4th over c to the 4th plus 2 times 6, which is 12. We subtract the 12 from both sides, and then we will get b to the 4th over a to the 4th plus c to the 4th over b to the 4th plus c to the 4th over a to the 4th equaling 13, just like so there. So let's show the 12 being subtracted from both sides, and then we get that equaling 13 here. And that'll conclude the video. So what I'm showing with this calculation is that it's going to relate to another problem where we take trig ratios from the heptagonal triangle. We will raise them to the 4th power, and we will sum them to find the answer. And this is the step before that, and I wanted to show that to you today. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.